Imagine a star so vast that if it replaced our sun, its surface would stretch far beyond Jupiter's orbit, swallowing every planet we know into a fiery abyss. Its face would not be calm, but alive. Boiling seas of plasma the size of continents, storms that rage for centuries, and waves of light so intense they could strip the atmosphere from a world in moments. Around it, space itself would shimmer with heat, and its glow would burn brighter than 1 billion suns combined. This is not science fiction. It is the reality of the universe's most colossal stars, hypergiants whose sheer scale defies the boundaries of human imagination. They are cosmic titans, living fast and dying young, their brief lives shaping the very chemistry of galaxies. Their deaths are cataclysms that forge the elements in our bones and scatter them into the fabric of new worlds. Tonight, we journey to the edge of the possible, to witness a star so immense it could swallow our solar system whole, and in doing so, reveal how even the mightiest forces in the cosmos are bound to the same fate as everything else. In the black ocean of space, there are giants so vast they defy the boundaries of imagination. Their surfaces boil with storms that could swallow entire worlds, their light blazing brighter than 1 billion suns combined. And somewhere, deep in our galaxy's spiral arm, there may exist one so immense that our entire solar system, every planet, moon, and comet, could vanish inside it like a grain of sand swallowed by the tide. Such a star is not merely an object. It is a furnace of creation and destruction, a living monument to the raw power of the cosmos. To grasp its enormity, we must first picture our sun, the heart of our solar system, so huge that more than 1 million Earths could fit inside it. Now, multiply that scale not by 2, not by 10, but by thousands. These are hypergiants, stars that measure more than 1,000 times the sun's diameter. Their atmospheres extend so far into space that light itself takes hours to cross from one side to the other. If one sat where our sun is now, its outer edges would reach far beyond Jupiter's orbit, swallowing Mercury, Venus, Earth, Mars, and the asteroid belt without effort. Yet for all their grandeur, these behemoths live fast and die violently. Born from titanic clouds of gas, they burn through their nuclear fuel with reckless speed. Their light is a beacon visible across galaxies, but it is also a countdown to an inevitable end, an end that will come not in billions of years, like our sun, but in a mere few million. And when their time is up, the spectacle of their death will rival the birth of a universe. Inside the heart of such a colossal star, the pressures are beyond comprehension. At its core, temperatures soar to hundreds of millions of degrees, a realm where atoms are stripped bare and forced into nuclear fusion at a ferocious pace. Here, hydrogen is fused into helium, then into heavier elements, carbon, oxygen, even iron, as the star races through the stages of its life. Every heartbeat of this fusion is an act of defiance against gravity's relentless pull, a constant struggle to keep the star from collapsing under its own unimaginable weight. But the balance is fragile. As the star swells to its monstrous size, its outer layers grow unstable, trembling under the sheer force of the energy trying to escape. Waves of stellar wind, streams of charged particles moving at millions of kilometers per hour, roar into space, peeling away its mass like a cosmic hurricane stripping the surface of a planet. These winds are so strong they can sculpt entire nebulae, leaving ghostly clouds of glowing gas drifting light years away, silent testaments to the star's fading strength. The light from such a star does more than illuminate. It reshapes the galaxy around it. Radiation floods nearby space, ionizing gas, triggering the birth of new stars, and erasing the fragile atmospheres of planets caught too close. Within hundreds of light years, its presence is a dominating force, a lighthouse, and a harbinger, a cosmic monarch whose reign is as brief as it is absolute. Eventually, the star's furious heart begins to falter. Iron, the final product of its nuclear forges, builds up in the core like a silent growing weight. Unlike lighter elements, iron cannot release energy through fusion. It is the dead end of a star's alchemy. The core's pressure rises to an unbearable threshold until, in a single moment, gravity wins. The heart of the star collapses inward at a significant fraction of the speed of light, compressing matter to densities that defy the imagination. This collapse is followed by one of the most violent events the universe can produce, a supernova. In the blink of an eye, the star's outer layers are blasted into space with the force of billions of nuclear bombs detonating simultaneously. The explosion shines brighter than entire galaxies, outshining everything else in the night sky for weeks. The shock wave tears through space, scattering the heavy elements the star forged in its lifetime, gold, silver, uranium, seeding the galaxy with the raw materials for future worlds. But the fate of such a hypergiant may be even more dramatic. If the collapsing core is massive enough, not even the blast of a supernova can halt gravity's grip. The matter continues to collapse into a singularity, forming a black hole, a place where space and time fold in on themselves, and escape is impossible. What once could have swallowed our solar system in life now becomes a predator in death, a dark star whose hunger is eternal. Around the newborn black hole, reality itself becomes distorted. Space bends and light warps, forming a halo of brilliance known as the event horizon, the ultimate point of no return. Anything that crosses this invisible boundary, whether planet, asteroid, or ray of light, is lost forever to the singularity at its center. Matter falling in forms a swirling accretion disk, a maelstrom of gas and dust heated to millions of degrees, glowing fiercely in X-rays as it spirals toward oblivion. These colossal remnants can reshape their cosmic neighborhoods. Their gravity influences the orbits of nearby stars, and their jets, beams of matter accelerated to near light speed, can extend for thousands of light years, blasting through interstellar space. In some cases, the black hole's feeding frenzy is so intense that it triggers new bursts of star formation in far-off regions, turning the death of one giant into the birth of countless others. Yet, for all their destructive potential, they are also keepers of the universe's deepest mysteries. What happens beyond the event horizon remains one of the most tantalizing questions in science. Inside, the laws of physics as we know them seem to crumble, replaced by something we cannot yet describe. In their shadow, we are reminded of our place, not as rulers of the cosmos, but as curious observers, staring into an abyss that challenges everything we understand. If such a hypergiant existed near our solar system, its presence would transform our skies and our fate. Even from light years away, its radiance would outshine the moon, casting alien shadows in the night and turning darkness into a restless twilight. The heat and radiation it poured into space would scorch the outer edges of planetary atmospheres, and the solar wind we know would be drowned in the tide of its own powerful storms. Move it closer, and survival becomes impossible. Its gravity would tug at the planets, pulling them into new, unstable orbits. Earth's climate would collapse under the flood of radiation, oceans boiling away in blinding steam while the ground cracked and burned beneath relentless heat. Within the reach of its swollen body, entire worlds could vanish, not just into its glare, but into its very substance, swallowed without resistance. And yet, it would not be malicious. The star would simply be following the script written for it by the cosmos, obeying laws older than galaxies themselves. In the cold ledger of the universe, it would not be predator or villain, only a force, vast, indifferent, and inevitable, shaping space in ways life can only endure for a fleeting moment before being erased. Such titans are rare jewels of the universe, scattered like sparks from the forge of creation. Astronomers have found only a handful, each one a challenge to our understanding of how stars are born, live, and die. Some, like the legendary UY Scuti, stretch more than 1,700 times the sun's diameter, their atmospheres so thin and tenuous that a spacecraft could drift through without ever touching a solid surface. Others blaze with a light so fierce it could be seen from millions of light years away, beacons marking the locations of the galaxy's most extreme stellar furnaces. Studying them is like reading an epic written in light. Telescopes capture their spectra, rainbows laced with chemical fingerprints that tell stories of the elements they are creating in their hearts. Observations over months and years reveal their pulsations, the slow swelling and contracting of their vast surfaces, each breath measured in days. Even their irregular flares and dimming hold clues to the storms raging in their upper layers, storms larger than any planetary system. Through these observations, we glimpse the chain of events that links such stars to everything we know. Without their short, furious lives, there would be no iron in our blood, no calcium in our bones, no carbon in the air we breathe. Every element heavier than hydrogen and helium was forged in the hearts of ancient giants, then scattered by their deaths, a cosmic inheritance without which life could never have begun. And so, the colossal star becomes both creator and destroyer. In one lifetime, it sculpts the fabric of its galaxy, weaving new stars into existence while setting the stage for its own cataclysmic end. Its light, traveling for millions of years, may outlive the star itself, carrying its memory across the void long after its matter has been scattered. To distant worlds, it appears eternal, yet within, its clock is always ticking faster than ours. Its death is not the end, but a transformation. The supernova's shockwave enriches vast regions of space, and the black hole or neutron star left behind continues to influence its surroundings for eons. From the ashes of its destruction, planets may one day form. On those worlds, life might rise, look to the skies, and see a different giant blazing there, never knowing their atoms were once part of a star so immense it could have swallowed their sun whole. In this way, the hypergiant's story folds into our own. Every breath we take, every drop of water, every glint of metal is part of a tale billions of years in the making. The colossal star's brief, furious life echoes in us, a reminder that even the mightiest forces in the cosmos are part of an unbroken chain of creation that binds us to the heart of the universe. From a distance, we might see the colossal star as a beacon, its fiery light piercing the blackness, a promise of beauty in the endless dark. But up close, that beauty would be overwhelming, its scale almost incomprehensible to human senses. Standing on a distant moon within its reach, the star would dominate the sky, filling it with a churning, seething sphere of color and motion, its storms rolling across its face like continents of fire. Such immensity forces us to reckon with our own fragility. Our planet, so vast in our daily experience, would be little more than a speck in comparison, an ember drifting near a cosmic furnace. Against the star's sheer size and energy, human history would appear as the brief flicker of a candle in a hurricane, easily extinguished, quickly forgotten, And yet, it is in the shadow of such enormity that our curiosity burns brightest. For this is the paradox of the human spirit. The greater the scale of the universe's wonders, the stronger our desire to understand them. We send our instruments, our light-gathering eyes, across the void, not because we expect to master these forces, but because we yearn to witness them. The colossal star may never know we exist, yet we shape our lives and technology around the hope of seeing it, of capturing, for a fleeting moment, the story it tells in light. In the end, the colossal star is more than just an object in the sky. It is a mirror to the universe itself. It shows us the raw extremes of creation and destruction, the fleeting brilliance of life on any scale, and the inevitability of change. Its size, its power, its fate, all are reminders that nothing in the cosmos stands still. Even the mightiest giants must one day fade, their grandeur dissolving into the silent dark. Yet from their endings come beginnings. The atoms born in such a star will drift for millions of years, mingling with gas and dust until they are woven into new suns, new planets, and perhaps new forms of life. Somewhere, someday, a world may stand beneath alien skies and wonder at its own origins, never realizing it carries within it the ashes of a giant that once could have swallowed whole solar systems. We are, each of us, part of that same cycle. The colossal star's story is our story, written across time and space in light, gravity, and the dust of ancient fire. And as we gaze up at the night sky, perhaps we can feel a quiet truth. We do not just live in the universe, we are made of it.